Yeah, I'm trying to bind you.
Trying to combine
I'm trying to bind you everywhere, right?
every
So this is my other student. Let's call this hand.
distinction.
Distinction. Yeah, so I'm trying to bind you everywhere, man.
Trying to about you everywhere. Trying to about you everywhere.
Everywhere.
Trying to about you
Exactly.
everywhere.
Thanks a lot. Hello, how you doing, man? So we have a question right here. So this is more the radical in square root. So let's say simplify, but in simplification, we have option here, right? This is the same question which is in here. Let's say simplify whatever you have there, and then you have to pick the options. So I'm gonna show you how to solve this. This is very easy. Okay. So first and foremost, I want to show the rules. Okay, the rules of the radical. If you have, look, if you have here, for example, square root of a times square root of a, you can separate them. Mean this root is gonna go for the first one, multiply, the root could go for the second one. That's the rules of radical. Okay. So same if somebody say, let's say for example 24. So this I could say, what is 24? 24 it could be 4 times 6. So it's like 4 times 6. So I can separate. I can say, oh, square root of 4 times square root of 6. But we know when you square root of 4, we get 2. So it's going to be 2. Square root of 6, no, there's no number. When you square root for 6, there's no number. But for 4, we know we're going to get 2. So that's one of the rules. You know what I'm saying? So same here. For example, this one here, this is another rule. If somebody give you, look, 5 square root minus means there's no number, means there's a 1. So it's like 5, but they must be the same thing. You see this? X cubed, and this is x cubed. So 5x cubed minus 1x cubed, we get 4x cubed. You know what I'm saying? But if this was 2, there's nothing you could have done because they are not the same. This here is like 5 orange minus 1 orange. But if you change here to 2, means nothing you can do because they're not a like term. But if it's 3, means these are like terms, then you can minus. You know what I'm saying? So now let's go to this question. So now we're going to break this in different ways. I'm going to say, okay, 24. So what is 24? 24 is like 4 times 6. So I'm going to say, okay, so here I have a 2. 2. 24 is like 4 times 6. So I'm going to say, okay, square root of. Okay, 24 means 4 times 6. So I'm going to say square root of 4. Separate. And then square root of 6. And they say minus. Okay. This one here, I can leave the same. I can say square root of 2 and this square root of 3 because I don't know what's going to happen then next. Okay, and the next things, look, this is square root of 3 power cube. So let me see if I can break this. What is 27? 27. Oh, I can come here and say, okay, this one 54 cube root of that one. So my intention, look, I want to get something with 2 so they can be like here. So 54, I know it's going to be 2 times 27. 2 times 27. So, okay, so 54. Look, 54. 54 is like, but there's a cube there, right? So equal to 2 times 27. But why I don't take 9 or whatever? Because my intention, I see here, there's a 2. So that's why I say 2 times 27. But we have a cube. Okay, what is 27? 27, I can separate. I can say this is 2 cube times cube root also of 27, because this is for both cube root, cube root. Okay, when you cube root 27, we're gonna get 3. Which number when you cube root get 27? Get 3 here. So here's gonna be 3, and this is gonna remind the way how it is. So I can say 3, mean this number here is gonna give us 3. So I'm gonna write 3 first, and then write my 2 cube root. Oh, so instead of writing this, I'm gonna write this. You know what I'm saying? Okay, let's go. So let's replace. So here 17 is going to remain the same. And I'm going to have here. Okay, I'm going to have what? 2 by a cube. And then minus. So 3 just a 3. 3 just a 3. But this term here, instead of writing all 54, I'm going to write 3 cube. Okay. So we have 3 out there. 3. And then multiply by all 54 is 3, 2 power cube. Means you replace this with that. You know what I'm saying? Okay, now we go. 3 times 3 equal to 9. Oh, see now they get like terms, okay? So now I'm going to say, okay, so that must be very clever. Square root of 4 equal to 2. So it's going to be 2 times 2 equal to 4. Because this is going to give us 2 here. 2 times 2 equal to 4. And then I have a square root of 6 minus. Okay, so now you see I have square root of 6. Oh, so I'd rather pull this one together, you know, Because why? My intention, I want to get like terms. So this is going to be 2, 2. Now I'm going to put single square root. Why am I doing that? Because I see this side here, there's a 6. So let me put this together. In a single square root, 2 times 3 equal to 6. You can only do that if this root is the same. You see, this square root, so you get square root of 6. So now I'm going to say, over. So now, you see, this is going to be 17. And then I get 2 cube. And then minus 3 times 3 equal to 9. And then this is going to be 2, but it's cube root. So you see, these are like terms. You know what I'm saying? From this rule here, I told you, like, if these are like terms, like 4 square root of 6 minus 2 square root of 6, you see, this is like both are square root of 6. So it's like 4 minus 2. You know what I'm saying? It's like 4 orange minus 2 orange, because these are like terms. Square root of 6, square root of 6. So 4 square root of 6 minus 2 square root of 6 is going to give us 2 square root of 6. So this is going to give us 2 square root of 6. Now we come here. Oh, it is also like term. Oh yes, 17 cube root of 2 minus 9 cube root of 2. Oh, that's going to give us 8 cube root of 2. So it's going to give us 8 cube root of 2. So here we're going to get 8. And then 2 cube root. Oh, okay. So then what happened then? Okay, so we say 4 divided by, okay, 4 by 2, 1 by 2, 4. Means 2 divided by 8 equal to 1 over 4. By 1, and this we get 2. So we get 1 over 4. And then we're going to write square root of 6. But over what? 2 square root of 3. You know what I'm saying? So that's going to be our final answer. In our final answer, so now we go to the option, but 1 times square root of 6 equal to square root of 6. So 1 times square root of 6 equal to square root of 6. Because 1 times anything, it does something. Over 4, and then 2 square root of 3. So that's our final answer. So we can come and check in the option here. We see that is going to be option number 2. You know what I'm saying? Look, man, I believe in learning from how I do things. If it's make sure you subscribe, and you know, you can just go and do donation to our Patreon page. I have a Patreon, I have a GoFundMe. You know what I'm saying? I have all the means of donation, because to make this project going, you know, any type of donation, the little that you think is too small for you, it could make a lot of change. And thanks a lot for all your time. You know, subscribe, don't forget, share this video, circulate to a lot of people. You know, because the meaning of this project, this program, is to help as many as we can. Okay, it's not only for one person or two, because you might think it's not helpful for you, but for somebody next out there, it could be very, very helpful. So thanks a lot, man. And you know, any donation that you did to me, it means so much. I appreciate it, man. It means a lot. Go to our Patreon page, go to our GoFundMe, because we need to have a lot of things. We need to put them together, like camera, you know, and a lot of equipment, so that we can improve on, you know, a lot of angle, a lot of aspects of these projects. You know, thanks a lot, man. I appreciate and I love you. Peace, man. Bye. You know, this is one of my students of knowledge. You know, she wanted to introduce herself. What's your name? Could you please introduce yourself?
My name is Kali.
Yeah.
I went to Southend Primary School.
Yeah, China Bantu. China Bantu is everywhere, right? So this is my other student. His name, what's your name? Matthew, yeah, he's grade 11, man. So his aim is to score distinction, right? So you promise, I want you to score distinction this time. And what's your name? Joshua. How much you promise me to score this time?
Distinction.
Distinction. Yeah, so China Bantu is everywhere, man.
China Bantu. Everywhere. China Bantu everywhere.
Everywhere.
China Bantu
Exactly. Thanks a lot, man. Appreciate it. Thanks so much. If you had to give advice, which advice would you give to the people or to the students?
Trust Amish.
Why would they trust me?
No, because it's really good. it actually has helped a lot. I redid first year for maths. It was my own fault, but also I didn't know a lot of the work. And Hamish said lots of hard questions, and it's demotivating sometimes to do the harder stuff. You just want to get done, but it's the hard stuff that makes you realize the easy stuff is easy.
Hawe